Hello everyone, this is problem number 128, longest consecutive sequence. This is Mr. Surodip and we'll be solving this question right away. So what the question states? The question states that we have to return a number. What this number is and what we are given with. We are given with a list of numbers. Alright, from this list of numbers we have to return a number. So as you can guess it, what the number 4 states, this the number 4 states that the longest consecutive sequence. This is the number, right? So how do we get the number 4? See, number four here says that one, two, three, and four. There are for this one, two, three, four. That's the length, right? There are four numbers that are in sequence, but they are in haphazardly arranged in the list, but they are in sequence, right? And four numbers is there in the list. That's why we're written four. And for this is nine, right? What does this nine means? Means there are numbers in sequence. There are nine numbers in sequence. As you can see, from starting from zero up to eight, all the numbers are present. That's why we are returning nine. And same for three. Starting from zero to up to two, all the numbers are present, right? That's why we are returning three. I guess you have understood the question. Now we are objective. Our objective is to find this algorithm, write this algorithm in big of n time. That means there will be one traversal only. No traversal. I mean, you can think like, okay, so if we just sort it, yeah, just sort it and then check whether in sequence they appear or not. That can be the approach, right? But the problem is, any sorting algorithm you use, the optimum is big of n log n. Among the all the sorting algorithms, the optimum is big of n log n. So we are not getting in big of n, right? So we have to devise some another strategy. Let's talk about the strategy right away. Let me open Excalibur. Let me just paste this example. Let me just take this example there. For this example, as you can see, so what our algorithm should do? Our algorithm first of all should search for the first element. For the first element, here it is one. For the what do I mean the first element? The first element of the sequence. The first element here is one, right? So we have to first find the first element, and then after we find it, we have to check how much the sequence continues. If there is up to five, then the answer will be five, but it is for up to four, right? So that's why answer is four. We have to check whether the elements or the numbers of the sequence are present in the list or not. So to check the presence, will be taking set. Yeah, we'll be taking set because it allows us to check to fetch elements in big of n times. That big of n times, actual big of not n, big of one. Yeah, it allows us to check elements in big of one constant time. That's a benefit, right? So that's how we'll be doing things. First, we'll be traversing. Yeah, we'll be traversing things. We'll be traversing from 100. We'll be traversing for every element. We'll be taking every element. So to 100, 200, and we'll be checking whether for 100, for this number, for 100, yeah, for 100, whether there is a number less than it. If there is, if there is a number less than, if there is 99, what we will be doing it. We'll be doing if there is 99, if there is not 99, no 99, then that means that 100 is the first element, right? 100 is the first element. If there is 99, then we'll be ignoring it. Okay, if there is no 99, we'll be taking as the first element of the sequence and then checking. We'll be checking that whether 101 exists. We'll be taking starting from here and see. We'll be checking whether 101 exists or not. It does not exist, right? So the length will the sequence length will be one, and same for four. We'll be checking whether four's the one decreased version, that is 3, exists in this list or not. It exists. That's why we'll be ignoring 4 and we'll be traversing next for which is 200, right? So for 200 we'll be checking where 199 exists or not. It does not. So we'll be taking, it does not, right? We'll be taking this number as the start of the sequence and we'll be checking whether 201 is in the list or not. It does not. That's why again it's the length of the sequence is one. We'll be returning the maximum length. That's why we'll be again traversing. 200 is done. Then we'll be traversing for one. We'll be checking for one. So one, whether zero exists or not, zero does not exist. So we'll be taking one as it is, and it will be the start of the series, start of the sequence. Then what we will be doing? We'll be checking whether two exists in this list or not. It exists, right? Then we will be checking three, whether three is existing or not. And after checking whether two exists or not, we will be increase the longest. We will be increasing the streak. Okay, to two. So one is increased to two. So for this the sequence is one, and for this two the sequence becomes two, right? And then for this three exists or not, three exists, right? Three is there. So the streak will be three. And then we'll be checking four or not. Yeah, so the four exists, so the maximum streak or the maximum length will be four. And whether five exists or not, five does not exist, right? Five does not exist. So what does that mean? It means we have to stop there. We have to stop here, and we'll be keeping the four and replacing with the maximum. There should be something that tracks every maximum streak, right? Because there is already one, and then there is the four streaks. So there will be something that tracks the whether there is something maximum of them, right? So we'll be finding the maximum length sequence, and that's why we'll be returning four because it's the maximum. We have seen the traversal, then we checked well, what is the maximum, and we're finding that four is the maximum. Let's code it up. Let's try to code it up. Okay, we have seen the approach. Now it's time to code. Let's open Leetcode and let's start from the beginning. So what we have to do? We have to convert to list. All right, we have to convert to list. We're converting that to list. From list to set. Yeah, num set to set nums. Yeah, we have converted. And then what we have to do? We have to keep track of the longest common consecutive sequence. So we are storing longest as zero first because there is no checking happening at this time. And then what we have to do? We have to traverse, right? Normal traversal. We'll be doing normal traversal here. Num num set, or you can say num set. Yeah, let's do num set. Yeah. So we're traversing what is there in the num set, and then with each traversal, what we'll be doing? We'll be we'll be checking whether this number, the previous number exists or not. I mean the previous version number for 100, whether 99 exists or not. Let's do that. Okay, for num -1 not in does not exist, then we'll be taking as the first, right? Taking num as the first, not in num set. Then we'll be stating that it is the first of a sequence of a potential sequence. Then we'll be taking it current num. We'll be storing that number into current num. All right. We have stored the number in the current num. That is all done. Then we'll be doing current streak. Current streak equal to 1. Yeah, because the number is a potential sequence, right? So as if you take only the number, that means the streak is 1. That means the length of the sequence is 1 because there is only one number. And then we'll be checking whether there is any other sequence or not. Let's do it. Let's create a while loop. Let's do it. All right. So what we'll be doing, taking num, we'll be taking current num, while current num in num set. If there is current num in num set, current num plus 1 in num set, then we'll be increasing the streak. All done. And then if what we should be doing, we should be comparing. That is later. We'll be just increasing the current term by one. Yeah. If it is done, then we'll be just swapping the putting the maximum streak. I mean, there can be any number of sequence, right? There can be multiple sequence present in this list. For example, if there is 101, therefore for 100 and 101, the sequence will be 2, right? And also there is 1, 2, 3, 4. Then 4 will be storing the maximum only. That's why we're keeping it longest, and we'll be replacing longest and will be and the current streak, right? The current streak that has been found in this iteration. After all that, let's return the longest. Let's see how it goes. Yeah, so it has been accepted. Let's submit it. As you can see, our solution has been accepted. So you may now think, what is the time complexity of this code? The time complexity of this code is big of n. But wait, you may ask that there is two nested loop. How it is big of n? It is hidden in the fact that the while loop inside the for loop touches every element, every element of every iteration only one time. Yeah, if it was a different case, for example, the for loop is running, and if every iteration, in every each and every iteration, the while loop does what? If the while loop touches every element, then it would be big of n square. But for this case, for each and every iteration of for the while loop touches only one element only one time. How is this case? Because the while loop, how when the while loop gets activated, it gets activated when the first element is found, first element of the sequence. Other than that, it is not activated, right? So that's when we are checking the sequence, the how the up to which the sequence is available, and the it depends on this if. Okay, so if does not gets activated every time. It only gets activated if it was only one. Okay, only what do I mean by the start of the sequence? If it was the start of the sequence, let's take a bad example. Let's take a bad example. For example, 99. If it was like this, 72, 5, 12. So there is a sequence here. For the sequence, inside while loop will be touching only every element only one time. How it goes like this? So for 99, for 99, there will be if case, right? Because 98 now 98 is not present, so while loop will be activated, and it will be checking is 100 is present here, but there is the 100. While loop activate, while loop will not be activated, right? And then, for example, for 72, we'll be checking whether 71 is there. This is not. So if it will be activated, and then we'll be checking 73 is there. No, there is a 73. The while loop is will not be again activated. So this will happen every for every case. So while loop will not activate in any of the case. When while loop activates, when then there is a possible sequence. For example, this 5, 2, 1. For this 3, there is 2, so if will not be activated. For this 5, there is 4. There's 4? No, there's the 4. So it will be activated if will be activated, and then we'll be checking whether there is 6 or not. That's when while loop activates, right? There is 6. There is no 6, right? So while loop does not get activates here. So for this 2, there is 1. So there is the question of getting inside if. All right. For this one, there is 0, no 0. Then we'll be inside inside if, right? And after getting inside if, what happens here? While loop, while loop gets activated and it touches almost every element, right? One, two is present, 2 and 3. It touches this element. So for every iteration, while loop only almost takes big of n, right? For every iteration, for big of n takes big of n. It's like, so the result is big of n. Although the result complexity is big of n. You can see for any example, you can take an example and examine. For if you take two sequence, if there is the list in the list, there is two sequence. For example, there is 6, 7, 8, and in the another sequence 1, 2, and 3. This is a basic example. If you're taking like this, right? See, for six there is five, no five, seven, there is six, eight, there is yeah. For this, it will be while loop will it will be activated and then while loop will be also activated. And if there is seven, so seven is there. So these two elements are checked. And for this, I'm skipping a bit. And for this one, again, if will be activated and while loop will be activated for this. So only four elements. Okay. So it's almost tending to big of n for every iteration of four. That's why we are taking the full algorithm as big of n. Actually this is a great question. Okay. Thanks for watching. If you have any questions, just comment down. And if you just like this type of content, click on the like button. And let's meet at another video. Bye for now.